Okay, so welcome to today's session. We have been going through the OCaml.org documentation pages. We've gone through a lot of them, and I want to cover your first OCaml program section today. Let me share the link in the chat. Of course, feel free to ask any questions you may have while we are going through the documentation. I will again make this video available on the YouTube channel after today's session. Well, let's get started. So this is the your first OCaml program page that we are going to go through today. We have been using the OCaml playground to try out all the examples. We installed UTOP in the previous session in the terminal. So today I want to use the terminal to teach you how to use Dune, the build tool with OCaml. So OCaml comes with two compilers. Right. One is for translating source code into native binaries, which is the executables that you're quite familiar with. Another one is to actually use the bytecode format. So OCaml also comes with an interpreter, so you can actually use the interpreter to execute code. Now for this session, so this is given here, two compilers. So for today's session, I am on OCaml 5.1.1. Okay, that's the current switch that we installed earlier, so I'm still on the same 5.1.1. And the way to create a traditional Hello World project is to use OPAM exec -- Dune init project hello. This is a Hello World project, right? So let me just do this in the temp folder. Okay, so now the temp folder, and if you've already done this eval.opam env, which is already there in the switch, right? So you don't need to actually call opam exec -- every time. So you can actually just call Dune directly. So this is a Hello World directory file. So let me remove this and do it again without the opam exec -- So we can just do Dune init project hello, right? And then if I check the hello folder, I have the same files. Okay, that's what is described here in this page. I do have the tree executable available on my system. So if I go to the hello folder, which basically lists the files in this project, right? So we have three main directories. We have the bin, lib and test. So the bin folder is for executable programs, and then lib is for libraries and test is for running tests. So the Dune tool can be used for running tests. You can generate documentation, you can produce packaging, metadata, you can create arbitrary files and so on, right? And the underscore build folder is where Dune stores all the files it generates. Okay, that's a typical directory structure you will see in any OCaml project. Now let's try to just build this project first. So the way to build this is to use opam exec -- Dune build. Okay, this is what is given here. Let's try this. So it builds and it generates an executable in this case, and let's run the executable opam exec -- Dune exec hello. Right, so basically this hello world program outputs the string hello world. Okay. Now you can do what is called as the watch mode. I think you will have seen it in a lot of other programming language ecosystems as well. So I have another terminal here. Let me go to the hello folder. So now I can run opam exec -- dune build -w is a watch, which means any changes that I do in the project, it will automatically rebuild and it will show the output. If there's an error, it will show the error in the output. I can also do the same thing for the hello binary here. Okay, it's also another command. So I'm just going to keep running this here. Now if we go back to the directory structure here, right? So we build this project here. We have lib binary main.ml, right? So let's see what is there in the it's just a let statement, and it basically prints the hello world string. This is like the main entry point. But in general, you will see that there isn't a main function. And there's no requirement that a project must contain a file with the name in order to produce an executable, right? And an executable OCaml file's entry point is its first line. So statements are just processed in the order from top to bottom, each triggering the side effects it may have. Definitions are continued to be added to the environment. A common example practice is to single out a value that will trigger all the side effects, like the main entry point. And in OCaml, we use the let open close parenthesis and equal to signify this row. Okay, so it's what you see here in the one line simple main ML file. Now we have seen the use of modules while doing the tour of OCaml. A module is nothing but a collection of named values. Identical names from distinct modules don't clash, and the standard library is a collection of several modules. Okay, so we have executed the hello world example from our hello project. Now suppose we want to use the printf function instead from the printf module, right? Instead of using print endline here. So I'm going to be using nano editor just to demonstrate these examples here. Later on I will show you how to set up your editor with all the goodies, right? So here instead of print endline, I'm going to just say printf dot printf %s/n and the same string, right? So I'm using a module here, and if you say this already has compiled and there's no errors here, so it's actually running in the second terminal. But I can also execute it to verify the output. Okay, because this one is already running here, there's a lock in the build. So let me close this one here. Let me go back to this and rerun it again, and it should print the same hello world string. Okay, right. So this is an example of using a function from a specific module. Now every file in OCaml defines a module once it is compiled, and references to external modules create dependencies. Now we cannot have circular dependencies in OCaml. So to create a new module, for example, I can create this new file called lib en.ml. Let's see what is there. in lib folder, we just have Dune project. So I'm going to create a new library module here called en.ml, and I'm just going to say let v is equal to hello world. Let's put the exclamation there, and then I'm going to update the main file in bin.ml, right, to use this module, right, %yes. Instead of saying the string, I'm going to say hello module en library dot v, right. So that's what we defined there in the library, right. So we're going to save this, and then let's run it again. Do exec hello. It compiles, it builds, and then it executes, and we get the same result. So this is an example of having a new file in library, and we are using that library in the main .ml file. Now you can also have these loaded in the utop session. The way to do that is to run OCaml exec -dune utop, right. So the whole environment settings gets loaded in a utop, and so you can actually refer to the libraries and modules that are there in the project. So I can say show hello.en. Show, oh, it's capital E N. Okay, so this defines the v that we had defined as a string. Okay, it is given here. So we can exit using exit 0, or you can just do hash quit from utop. So if you want to load a project and try out some of the modules, if you don't understand what the function does, then you can also load the project in utop as shown here. Now if you add a file named hello.ml in the lib folder, right, this is already a hello project, right. If you had a similar name ml in the lib folder, Dune will consider this as a hello module, and it will make the en unreachable. So in that case, you want your module en to be visible, so you just have to explicitly state that. You will see a lot of these examples in OCaml projects. Okay, moving along, let's learn about module interfaces. So when we looked in this utop output, we saw that the module has this definition v, right. So this is kind of a API that is shown for each module, and this is called a modular interface. The .ml file defines a module, the .mli file defines a module interface. Okay. So the important thing here is that the MLI file name should be the same as the module file. So en.mli is the module interface for en.ml. Very important to remember. So let's create a en.mli module interface for en.ml. So let's clear this. So this has only v definition. So I'm creating a new en.mli, and here I'm defining val v as string. Now I'm not including the other actual definitions that you saw in utop, right. It's only the actual definition, the values here. That is only the declarations between the signature and end from the show output or return. Now module interfaces are also used to create private definitions. So if a definition is private, it is not listed in the module interface. So let's see an example here. let's update liben.ml. We only have v, so let's add here hello is equal to hello, and let v is equal to hello concatenated with world, like this. Okay, so you have hello and v definition, but what is there in the MLI file? It's only v. So hello is basically private. Now suppose if we update bin main.ml, let's call en.hello, right, instead of v. Now this should basically throw an error, because the definition of hello is basically private. So let's try to build this, and rightly it says that unbound value hello en hello. So basically this one is private, it's not in the MLI file. Only we have v which is exposed here. So this is an example of module interfaces. Of course we can do a separate session on modules, but I am only covering the basics here. Now let's look at defining multiple modules in a library. So let's create a new file libes.ml for Espanol, Spanish. Let me just copy this string here, hola, right, and let's update main.ml file to use this printf. Let's revert this back to v, which is what is exposed as a public interface, and then I'm just going to again call %yes/ and print. I'm going to use the es module and I'm going to call v. So when I now build and execute this, right, it compiles and now it prints both hello world from the en file and also from the Spanish es file, right. So this is like example of multiple modules in a library. Of course, OCaml has a very active community of open source contributors, and there are a lot of packages available from OPAM package manager. Now to illustrate one example here, right, let's wrap our result v hello world into a web server. Like you make a request, it should return hello world as a response, right. So Dream is Anton's web framework. Let me show you that as well. So it's actively being developed. I do want to do sessions on this Dream web framework as well. So it's quite nice, simple, elegant, easy to use. There are some tutorial sessions that I can cover if you want to like work on a lot of web applications, maybe port existing web applications into using Dream web framework, for example. So we can go through this as well in future stream sessions. Anton is also streaming on Twitch, so he does live coding, so you might want to also subscribe to his channel. But let's work on this example here. We want to first install the Dream package. I have already installed this here. So if I do opam list grep Dream, that I already have 100 alpha 5 installed on this 5.1.1 switch, right. And I can also do OCaml show -f version dream, which will also result in the version to be displayed. Okay. So what we're going to do is we're going to wrap this V into the dream call. So let's update main.ml. Let's remove this. We're just going to call dream run the router if there is a get request function for the request HTML, and I'm going to call hello.en.v close or the parenthesis, right? So in order to use the dream package, we also need to update the bin Dune file, which says I am depending on the dream package here. So this Dune file, it says I have an executable, public name is hello, this is the main file, and having libraries hello and dream. Okay, this came in by default, but now I am adding the dream as part of this. Now I can do OCaml exec -dune exec hello. It should build a project with the dream. It should start the server, so it's running on local host. This is Control C to stop. So I can do curl localhost :8080 and it turns the string hello world, right? So it's a very simple example of how to bring in dream into your project. Good. Let's continue. Now suppose we want to display this hello output, right, as a list of strings in UTOP, right? We want like this output. So there is a way of doing it automatically. So here they give an example of ppx show to pre-process. So let's quickly go through this example here, because I have installed ppx show. But if you don't have it installed, you can use OCaml install ppx_show on your system. And then we need to update the libdune. It only have library hello. So what we want to do is add the pre-process step ppx show, and we want to use libraries ppx show.runtime. Okay. So what does this say? The libraries ppx show runtime means a project is using the definitions found in the ppx show runtime library, which is provided by the package ppx show. Preprocess says that before compilation, the source needs to be transformed using the preprocessor provided by the ppx show package. Let's see what we are doing here. We are updating two files here to produce the required output. So we have lib.en.mli, the interface. This we are going to return a list of string, and then we define string of string list, which converts a string list to a string. Okay, and then we are updating en.ml. Remove all of this, defining string list pp as show string list. Then we're defining string of string list as format asprintf at %a at string list pp, right? And then we're defining v as string dot I'll explain this in a minute. Char hello using an OCaml library. Okay. So V has the type string list. We are using split on char, this one, turning the string into a string list, turning this into a string list on space characters. It's defined here. String of string list is just takes the string list and outputs it, applying the formatting basically. String list pp has this type formatter string list unit, which means uses a custom formatter that turns the string list into a string. Okay. So finally we update bin main.ml. Let's remove the dream stuff. This call print nline hello.en string of string list b. Hope I've not made any errors, and this should run and it should convert that string into a string list and output as hello using an OCaml library. This is the expected output here. Okay. Right. So I already talked about Dune. We can do a separate session on Dune tutorial. Now the last section I want to touch upon today is that if we look at the hello folder now, we have the lib with these interface files and modules, of course Dune. We've not looked into testing yet because we have the OPAM file and Dune project files, and then the underscore build is where Dune builds all the artifacts. Okay. Then we have the bin folder where we have the main.ml file and the Dune file. This is the structure that is generated from Dune, but we can also create a minimalist setup if you want to create a bare minimum project, right? So let's do this. We do make dir minimo, go to this folder, and then I'm going to just create 3 files, the minimalistic that we want for a project, Dune and minimo.ml. Dune project, Dune, minimo.ml. What should these contain? So in this tutorial they say lang Dune 3.6, but we need to check the Dune version that we have in our system, which is 3.14.2, right? So let's use 3.14. Dune project is lang Dune 3.14. Then we have to define Dune, which basically has the output executable name, which is minimo, and then we have the minimo.ml file where we just are going to call print nline my name is minimo, right? And then we are just going to execute this. OPAM exec Dune exec /minimo.exe. It builds and it prints the output from the printed line, which is my name is minimo. Right. Now note that minimo.exe is not a file name, right? This is how Dune is told that we have to compile the minimo.ml file to use the OCaml's native compiler, right? Now in OCaml, an empty file is also valid OCaml syntax. Okay. So this concludes this session. I would encourage you to try this out again on your system. Please feel free to reach out to me if you have any specific questions, let me post the link to the YouTube channel where this will be made available. I'll also share the link where I have updated the notes for the Twitch GitHub repository, where you will be able to refer to the notes, right? So you should be able to get all the videos from here. The GitHub repo with all the notes are available here. Okay. Please try these on your system. Go through each and every example, and feel free to reach out to me on Twitter or on social media if you have any questions. And this will basically concludes the understanding of a basic OCaml project that uses Dune as the build system. Let me stop the recording here.